Actually. All right, good morning, everyone. Welcome back to school. Welcome to AP Calculus BC. I'm gonna have you guys start off by doing this for me. This is also on the top left corner of your syllabus. Want you guys to, you can join the class. So you're gonna go to on your phone, send a text to 81010, and then at 688-4C93. That will allow you to join this class. And I'm going to be using Remind to send out if there's help sessions coming up, or if you want to, well, I'm also going to have help sessions on the day of any of your tests or quizzes. And so if you want to join virtually, I'll also send out a remind with the Teams link the day or the morning of, and then you can, if you're at home, you want to join in the help session, you can click on that link and join their help session, join the help session. And I'll also record each of the help sessions. I'll record each of the notes, each of the class, each of the days that we have class and we have notes. So if you happen to miss the class, or if you want to look over, or if you want to watch portions of the class, I'll have that updated on my website on a daily basis. They want us to do things through Canvas, so I am going to update things on Canvas, but that's going to be bare minimum. I'm going to do most everything on my website. So you guys can take care of that now, and then so this is my website, mryangteacher.weebly.com. Once you go to that website, it'll take you to the AB page, and you need to click on BC to go to the homepage for BC. So on the homepage, you're going to see class notes and video, calendar, link to the calendar, which is in your packet. Every new packet I give you, I'm always going to put the calendar, the updated calendar, on that first page. Now, syllabus link is also there. So we're going to start off going directly into limits. So if you guys can do this for me, if I didn't teach you last year, if you guys can do this for me, if I taught you last year, I know you know where it is. But if you guys can go to Calc BC, and then you'll see the drop down for class notes, and then just go to that Unit 1 limits page. So it looks something like this. I think I pulled this screenshot from last year, so the dates are a little off. But this will be where you're going to be pulling your notes. If you the keys, any keys that for your homework, I'm going to put on this page. Any links to daily videos, I'm also going to put on this page as well. So if I can walk around and have you show me so that you can get to this page. Again, just do this if I didn't teach you last year. If you're new with me, then show me. Otherwise, I know don't worry about it. All right. So again, mryangteacher.weebly.com. Click on that Calc PC and show me that you can get to that Unit 1 limits page. Yeah. Good. Yeah. Yeah. Just, yeah. Okay. That's fine. I'm going to highlight a few things from your class syllabus. The grading scale is the same across all your classes. Major test, 55%, minor quizzes, 35%, practice, 10%. Now, for some units, for some of the smaller units, I may just have a quiz grade for that unit. And then for a larger unit, I may have a minor and a major assessment. Just depends on the unit. All test quizzes will be closed notes. There's no final exam this semester, but we will try to do a review for AB content. We will be able to get through all of AB content by the end of this semester. So we are going to have the summative or practice FRQs. That's probably going to go into one of your test or quiz grades, but there's not going to be a final exam category for this semester. But we are still going to do AB review or have some sort of AB review quiz or test at the end of the semester. Homeworks will be assigned and checked daily. We're going to have homework starting tonight. We're going to, this semester, we're going to cover a ton of content. So it's a lot this semester. We're trying to have to cover all of AB content by this semester. Next semester, we'll feel like, okay, things are slowing down. And we'll be able to get through all of our new content by next March, and we'll have 2 months to do AP review. But if you're coming into this class from AB, then everything this semester will be reviewed. So it's either going to feel like so much material or it's going to feel like review, depending on which class you're coming from. Homework will be signed and checked daily. I'm going to be walking around each day at the beginning of class to just look for homework completion. I'm going to be posting the solutions on my website every day. So I'll encourage you guys to do your homework and also check your homework. We may have a little bit of time at the beginning of class to go through homework problems. But if we don't have time, then I will try to have semi-regular help sessions in the mornings so that you guys can come in and ask questions if you're stuck on homework or you want to go over some homework problems together. Homework will be worth, I said 4 points, but I think I meant to say 5 points. And then if you are late with any of your homework, you can still do your homework and earn 4 out of 5 points. So it has 3 and 4, but I meant to say 4 and 5. But homework is only 10% of your grade, but still, those are free points. You just do your homework daily. You can earn all, if not majority, if not all of your points just by showing your homework on time. Okay, cell phones. Today, you're going to have them because you guys were signing up through Remind and also making sure you can get to my website. But starting tomorrow, you're going to be putting your phones up on the wall here. And I'm going to give you a seating chart tomorrow. So when you walk into class tomorrow, you're going to find your name on the wall, on the board. And then if you see right now, there's a number at the top left-hand corner of your desk. So tomorrow when you sit in your assigned desk, you're going to see that number, and then you're going to place your phone in the number that corresponds with your desk number. All devices and laptop computers are to be put away off your desk during classroom instruction time. You will have an opportunity to recover each of your, I'm going to say each quiz and test grade up to 75. I'll hold morning help sessions on the day of your quiz and test. We're jumping directly into limits, and we're going to have an assessment next week. So I'm going to have help sessions starting tomorrow at 7:45. So if you're stuck on some homework problems tonight, and you want to go over some things tomorrow, I'll be available tomorrow 7:45. I'm also going to send out a remind this afternoon so that we're connected and you can see that you can receive my remind message. Okay, this is the textbook that we're going to be using. This is an old textbook here. This is 3rd edition. I think they're going to give us the 4th edition. I think Media Center will probably receive it in the next week or two. I don't think you're going to need a textbook. I photocopied the exercise pages that they're going to need, and I put it in your packet. Not this, in this Syllabus packet as well as every other packet. So if you just come with your note packet and a notebook to do your homework, that's all you need. You don't have to have a textbook. But I know some students want to have a textbook just to have resource, just to have at home. And so I will let you know when Media Center has received the textbook, and then once I can make an announcement once they're ready for you, and then you can just go during your lunch period, once it's in, to check out the textbook, and then you just leave it at home. There's no reason they should have to bring it into the class. But if you feel like you want to have just a resource textbook at home, you can do that. But I already pulled all the homework from this textbook, and I don't want to do all the homework. I think the 4th edition may have homework problems that are basically the same, just in a different order. So don't do the homework off the new edition. But if you want to just look at the examples and have a textbook at home, you can have that. But I will have all the exercise pages for you, printed out for you in your packet. Okay. Okay, graphing calculator. Hopefully we all have one. Yeah, 83, 84, any variation of 83, 84 is ideal for this class. And then bring some sort of third binder or folder where you can do your homework problems. But I will have, just like in your senior packet, I have guided notes for all your notes. So hopefully that will save time in terms of having to write out a lot of problems. And we talked about textbooks. So again, it's going to be the 4th edition for the Sullivan and Miranda. I do have a class set of graphing calculators. So if you forget yours, you can always borrow mine. But on the AP exam, I would say roughly the AP exam is mostly non-calculator. So I would say like 2/3 of the AP exam is going to be non-calculator, and then about 1/3 of your AP exam is calculator. We're going to start off the year without using the calculator much, and then probably halfway through first semester, we're going to do a little more work with the graphing calculator. So this is our pacing for BC calculus. We're going to cover all of AB topics first semester, so we're going to go through this pretty fast. So really encourage us to do our homework on a daily basis to keep up. And then second semester will be our BC topics. So some of the miscellaneous smaller BC topics, I'm just going to merge it together and call it a miscellaneous topics unit. And then parametric polar is a big unit, and then series will take a couple of weeks to get through. But even then, we should be able to get through all of our new content by mid-March. And so we'll have a good close to 2 months to do AP review. And your AP exam is going to be Monday morning, May 12th, 8 a.m. Okay, so this is the Calc AP exam format. I believe it's longer than your AP pre-calc exams, about 3 hours and 15 minutes in total. So you're going to start off taking the multiple choice section, 45 questions over an hour and 45-minute period, and then free response. So free response, 6 problems. Each problem, you're going to be given roughly around 15 minutes to work on it. But then you can spread out your time however way you want to over that course of the 6 problems. You're going to have 3 problems that are shared between A, B, and BC, and then you'll have 3 problems that are specific just for your BC. So there is some overlap between the A, B, and BC exam. Sorry, this is, I pulled this from my AB page, but basically the first half of fall semester will be focus on differential calculus. So derivatives is just a fancy word for slope. So if you understand the concept of slope, which is steepness, then we're just going to explore that idea. And then the second half of the semester, we're going to do definite integrals, which basically is just area. So area and slope are very much related with one another. They're basically inverse process of each other, and we're going to explore all of this AB concepts by the end of this semester. Sorry, that was a page for my AB. So I'm going to start checking homework tomorrow, but we can get through some of the notes today. All right, so if you guys can turn in your packets. So if you turn to your calendar, this is what we're going to be going through this week. So today, I'll just start going over some limits and properties and rates of change, talking about that. And your homework is, I put it directly in your packet. So page 85, 89 is just a few pages past this page. And then there's also AP practice page. And I also put that in your packet. So I'm going to ask you guys to put your work on a separate sheet of paper and not directly on the homework page. I want to see your work. So if you're just scribbling your answers, sometimes it's hard for me to see how much you've done. So, all right, so we're going to get through all of most of our limits unit by the end of this week. And we're going to go directly into having a test next Thursday. So we'll have most of next week to just do review. I'll give you a couple of test reviews that you can work through, and we'll also be able to have some time in class to do review Monday and Tuesday, next Monday, Tuesday. Okay, this is a summary page, and I will we can review this summary once we get into once we cover most of our topics. All right, let me read through our first set of notes here. Okay, so Mr. thrust distance from his house is modeled by the function d of t. While riding his bike to the store, he realized he dropped his wallet, turns around, and he turns around to find it. After finding his wallet, he finishes his ride to the store. So we can see that as minutes pass, this graph indicates how far he is from his house. So we see that he's getting further and further away from his house, and he must have realized at some point that he dropped his wallet. So he's backtracking, and then he's his distance is going to get near. He's basically backtracking and riding his bike back towards his house. And then he must have found it here, and then he starts going towards his destination, moving further and further away from his house. So he ends up 8 minutes in, he ends up 1,300 meters from his house. So part A says, what is his average speed or his average rate of change for his trip to the store if he arrives after 8 minutes? So if we want to find average rate of change, we should do change in what? Change in, yeah, so change in whatever, change in position over the change in time, change in meters over the change in minutes. Okay. Yeah, so try that, see if you can, basically you're gonna identify two order pairs and then do change in position over change in time, and that will give us our average speed. Okay, so we know that 0 minutes in, he's going to be 0 meters away from his house. He's going to be at his house. But then 8 minutes in, he's going to be 1,300 meters away from his house. So we know that he's going to cover 1,300 meters over an 8-minute period. So we divide that, we get 162.5 meters per minute. Okay, try part B and C. What is his average rate of change between 2 and 6 minutes? And then estimate his average rate of change between 2 and 3 minutes. We can just set up the slope formula. We don't have to find those estimated values. Okay, so we can have an idea how fast he's going over an interval, right? Over an 8-minute period, we can find out his average speed over a 4-minute period, over a 1-minute period. But then, is it possible to know how fast he's going at a specific instant? The issue is that if we want to find how fast he's going at an instant, that means you only have one time available, one order pair available. And if we want to do slope, we need two sets of information, right? We need two locations, two order pairs. So we call that instantaneous rate of change. And this is where calculus is going to help us, allow us to find the exact rate of change at a specific moment in time, where otherwise with slope, we would need two order pairs. But we can find a really close estimation to his instantaneous rate of change or his speed at 2 minutes if we just pick 2 points that are what? Yeah, really close, right? Really close to each other and as near to 2 as possible. So here's an example. We can just find his location at 1.999, or even more accurate by adding more decimals. So if we just do d sub 2 minus d sub 1.999 divided by 1 minus 1.999, this won't give us the exact, but we can get a really good approximation, right? The closer we are to our destination or to our target, then the better our accuracy is. But with calculus, we're going to be able to do something a little cleaner than this. We don't have to worry about finding 2 points that are really, really close to each other. We're going to just be able to rely on 1 point, and we're going to get to that next week. So part E, give a rough estimate of the instantaneous rate of change at 2. So as a rough estimate, I'm just going to pick 2 points that I can easily identify. So your approximation may be different than mine, but I'm just trying to find 2 points that I can identify and find the rate of change between those 2 points. Okay, we're not going to do every problem on this page. Just want to kind of highlight some function notation from number 2 here. It says B of t represents the buffalo population in the US, where t is measured in years since 1800. Part A, what does B of 90 represent? Yeah, it'll be the yeah, good. Yeah, so 90 years after 1800, the number of buffalo, yeah, you're right, number of buffalo in US in 1890, right, or buffalo population in that year. So what is B of 50 minus B of 0 over 50 minus 0? What does that represent? Yeah, exactly right. What is the average rate of change of buffalo population per year between 1800 and 1850? So what is part C? What is that trying to represent for us? B of 32 minus B of 31.999 divided by 32 minus 31.999. It's trying to give us an instantaneous at rates of change in buffalo population in that year, right? We know it's not exact, but it's trying to give as accurate as possible by picking point that's purposefully really, really close to 32, right? The closer we are to our target, the better our approximation for our tangent, right? It's trying to approximate that tangent line rate of change. Okay, bottom of the page is much the same, so let's skip that. Okay, let's talk about limits. Okay, definition. Limit is very much related to the y value of a graph, but there is some distinction here. Limit is the y value that a function or graph is approaching as the x moves closer to a given constant. So as it approaches, I'm going to indicate this from both sides. And there needs to be a consistent movement towards the same y value from both sides. And the key word here is approaching, okay? Because if I just want to find the function value, then I'm just going to just zero in at that point. I don't care what's happening around that graph. I just want to know what the y value is. But if I'm trying to find a limit, I care more about the approach as we get closer to that point than what's actually happening at that point. So as x approaches 2, we're going to try this example here. As x approaches 2, then f of x approaches And we're going to try to figure out, is there a consistent movement towards the same y value? So here is how I want us to do this, just as for visual, to make it visually easier to understand limits. If I want to approach 2, or if I want to find out what is the limit as we approach 2, then we're going to find 2 points that are relatively close to we're on the graph as we get closer towards 2. So I'm going to pick a point to the left of 2. I'm going to pick a point to the right of 2. And I'm going to draw an arrow towards 2 along the path of the graph. And so the question is, are those 2 arrows headed towards the same y value? Yes, right. And they're both approaching what? Approaching 1, approaching y value 1. So therefore, the limit exists. Okay. Now, the order pair is also at 1. So right now, your limit and your order pair, they don't look like they're any different. Because the approach, the arrows are the same as if I just want to find the order pair. And so we say the limit as x approaches 2 of f of x is equal to 1, but then f of 2 is also equal to 1. Now, this graph looks similar, but there's a hole. Let's see if there's any distinction here. So if I want to find limit as x approaches 2, again, I'm going to pick point close to 2 on both sides of 2. And I'm going to purposely draw an arrow towards 2 because I'm approaching 2. And again, are those 2 arrows headed towards the same y value? Yes, they're both headed towards a y value of 1. Okay. But what about the order pair? F of 2 is what? Undefined, right? You can say undefined, or you can say does not exist. Any of those notations is fine. Okay, what about this one here? Limit as x approaches 2 of f of x. This is also what? Also 1, right? Even though the point is living here, the graph is headed towards a different destination, right? They're both headed towards 1, but f of 2 in this case is what? 3. Okay. So here's a general observation that we can make between order pair and limit, and that is if there are no breaks in the graph, you're not going to see any distinction between limits and order pair. However, if there's a break in the graph, it could be a hole, it could be an asymptote, it could be 2 different branches headed towards 2 different y values. If there's any sort of break in the graph, then you're going to start seeing a distinction between limits and order pair. But if your graph is continuous, it's like as if there's no distinction. All right, so let's see if we can try these problems here. You're either going to find the limit or you're going to find the order pair. And then for limit, again, practice picking 2 points on both sides of your target and then draw an arrow towards your target. If you could convince yourself that your arrows are pointing towards the same destination, then you know for sure your limit exists. But if your arrows are not pointing to the same destination, then you can say your limit does not exist. Okay, so look at your arrows for limits. Now, if it's an order pair, then just zero in at that point. Okay, if there's a hole there, if you don't see anything defined at that x value, then undefined. But if there is a point that is defined on that x value, then the order pair exists. All right, so you can try. Let's try those 8 problems, and we can go over them in a minute. sometimes when we are finding limits, if we see a hole, sometimes that distracts us because that hole, our tendency is to think that, okay, nothing's defined there because there's a hole there. But if I can pick points on either side of the graph, and if I can draw an arrow and the arrow are headed towards the same hole, then the limit does exist. All right, so check your answers 1 through 8. Any ones you want me to go over with you? Okay, number 9. Give an interpretation of the statement limit as x. Give interpretation of the statement here. How would you say this? Okay. As x approaches 7, what's f of x doing? Yeah, it's approaching 10, right? So the key word is approach. Sometimes a hole can throw us off, but as long as we can convince ourselves that both sides of the graph is headed towards the same y value, then we know our limit can be said to approach 10, or our limit can be said to equal 10. Okay, so a limit does not tell us the value of f of x. Sometimes it does, but many times it doesn't. It just tells us what the function is approaching. So true or false? F of 1 equals the limit as x approaches 1 of f of x in all cases. False, right? It's possible, right? If the graph is continuous, then your order pair and your limit will always be in agreement. But if there's a hole, if there's an asymptote, then it's not always true, right? Here's an example of something that's where the order pair and the limit is not lining up. And then true or false, f of 1 does not equal to a limit in all cases. False, right? If the graph is continuous, then we know that there will always be in agreement. Okay, let's see how much of page 3 we can do. I'm going to walk around and see if I can answer any questions, and then I'm also going to put the answers up where you guys can check it. Page 3. A few minutes remaining. I don't know if you've heard about our new bell schedule this year. So we have 3 bell schedules: Schedule A, Schedule B, and Schedule C. So we're going to be following C schedule this week, and that is where we have homeroom. So homeroom will be after second period, but normally we're going to be following Schedule A and Schedule B. So Schedule A is for Monday and Friday. This is where every period is going to get the same amount of time. But then Tuesday, Wednesdays, and Thursdays, there's going to be advisement. So advisement is different from your homeroom. Advisement, you're just going to stay within your second period. So the second period, so Tuesday, Wednesday, Thursday, we'll have extended second period, but we'll be doing whatever advisements, things we need to do for that day. To do student success skills, but yeah, after this week, we're going to be following either Schedule A or Schedule B, depending on the day of the week. Okay, so last thing, if you are okay, so tonight your homework will be from page 5. So your exercise homework problems that I photocopied from the textbook is between pages 5 and 8, and the homework assignment problems are directly in your packet, and the homework pages and specific problems are on your calendar. Okay. I will send out a remind tonight so that you guys can know exactly where to go if you want to check your answers. I will have the solutions on the website on that chapter P page, and then I'll also send out a reminder that I'll have a help session tomorrow morning, 7:45. If you want to go over any problems with you. All right, thanks everyone. Looking forward to a great year with you all. Yeah, that's what's been limited on time. Thank you. Well, I think I'll do that. Yes, no, I see them like 10 weeks. Leave this year. It's always like the student. But you get down to this. Just make a group on Instagram.
Basically, they just like.
So let's just get it up.
Yeah.
Limits. It might be. Supposed to be.